FlippedHarber for Algebra 2, and in this video we're going to talk about rational expressions and then multiplying and dividing these rational expressions. Now our objectives for this lesson are to identify rational expressions, that is, what the heck are they? We're going to look at how to multiply rational expressions as well as how to divide rational expressions, and then we're going to take a look at solving some simple rational expressions. The outline for this video, we'll talk about what a rational expression is and briefly look at a rational function. We're going to look at simplifying rational expressions. Then we'll take a look at multiplying and dividing rational expressions, and then end by again solving some simple rational equations. A rational expression is simply a fraction that has a polynomial in the numerator and in the denominator. So we're looking for a fraction with a polynomial, that is some x squared or x cubed plus some other x's, all added or subtracted in the top and in the bottom. Now, as with all fractions, the bottom of these expressions can never ever equal 0. That just doesn't make sense to have a 0 in the bottom of a fraction. So we can never plug in a value for x that might make these rational expressions go to 0 on the bottom. Going to 0 on the top is okay as long as we don't have 0 in the bottom. Now here is a rational function. It's just a function that is equal to a rational expression. Now we're not going to do anything with this today. We're actually going to spend a whole section talking about rational functions later. I just wanted to show you what a rational function looks like for right now. Now when we want to simplify a rational expression, really what that means is that we want to reduce it. Just like when we first learned how to reduce fractions like 2/4 down to 1/2, we did that by dividing out and canceling numbers that were in both the top and the bottom of the fraction. Now the same thing is going to happen here, but of course, since this is algebra, we might be canceling some letters along with those numbers, or we might actually be canceling out entire polynomial expressions, usually binomials, between the top and the bottom of these rational expressions. So let's go ahead and take a look at how some of this happens. Now here we see a pretty basic rational expression. These are polynomials. The 10xy is a polynomial. You know, it's just not a polynomial that we do a whole lot of work with here in Algebra 2. But we have a rational expression, so that means that we have a polynomial on the top and the bottom. And I want to start dividing out. That is, I want to start canceling things that occur in both the top and the bottom of this fraction. Now this is a division process, so we can only cancel things that are multiplied together. And fortunately, everything that we see here in the top, everything we see here in the bottom, is multiplied together. So the first thing I'm going to do is deal with these numbers, these coefficients in the front. And obviously I can cancel out a 5 from the top and the bottom. Now that's going to leave a 2 on the top and a 1 in the bottom. I'm not going to bother to write that 1 though. I have some x's on the top and on the bottom, so I'm going to cancel this x on top with one of the x's on the bottom, and that's going to reduce my power from a square down to a 1. Now I don't have any y's on the bottom, so this is as much as I can cancel, and my final simplified rational expression is 2y over x. So it's exactly equal to what was above. It's just been simplified down. Now let's take a look at this one. We have a polynomial, top and bottom. We have x minus 3 on top. We have x plus 7 on the bottom. Now you would probably be very tempted to go ahead and try to cancel these x's and say, well, the x over x is 1 and what I have is negative 3/7. But that does not work. The reason it doesn't work is because of the addition and the subtraction that are going on. So this is actually as simplified as it gets. Don't get tempted to cancel these things that are being added together through this division process. We can only cancel out things that are being multiplied together. Now here's one that looks like, okay, you know, I want to cancel the x's, but I can't because of the addition and the subtraction. I want to cancel the 4 and the 2. I can't because of the addition and subtraction. Well, if I factor the top, now this is something that we're going to see a lot with rational expressions. You want to factor the top and the bottom as much as you can. These rational expressions are easier to work with if they are factored out. So I'm going to go ahead and factor out that x squared minus 4. Now, maybe you didn't recognize it right away, but it is a difference of squares, so you should recognize how to factor it into x plus 2 times x minus 2. And now we're going to actually cancel out this whole binomial, x plus 2 on the top and on the bottom. And what we're left with is x minus 2. So we actually went from a rational expression, that is a fraction, to just a regular old polynomial expression. We don't have a fraction anymore. And that happens sometimes. Now, when we're multiplying rational expressions, this is just multiplying fractions together. This should really feel somewhat comfortable for you. But what I want you to always try to do is always try to factor the top into all the parts that you can and factor the bottom before you multiply. You actually want to do the canceling, the reducing part of the rational expression before you actually multiply. So I want to cancel as much as I can between these two rational expressions before I actually multiply. Now, this one's not too bad. I'm going to really go ahead and pull it right apart for you just so we can see what's going on. So my 2x y cubed became 2 times x times y times y times y. And I factored out the x's in the 6x squared so that we see everything separated out. Now, whatever I can cancel between the top and bottom of a fraction, I'm going to go ahead and cancel. So I'm going to go ahead and get rid of a y on the top and the bottom of that first fraction. Now that's just good sense even without multiplying. But if I can cancel stuff between the tops and the bottoms of the different parts that I'm multiplying together, I should go ahead and do that as well. So I'm going to get rid of another y because of that y down there with the 4. Now I got rid of all the y's that I can. I'm left with one single lonely y in the top. I actually don't have any x's that I can get rid of because there's no x's across the bottom, but I can deal with these numbers. I have a 2 right here in the top. Well, there's a 2 hidden inside this 4, but I'm not done there. There's a 3 hidden inside this 6, and lo and behold, these 2's will cancel as well. So all of my coefficients actually divided out, and what I'm left with coefficient-wise is a 1. And on the bottom, that's all I've got is 1. Everything canceled out. The 3 canceled out, the 4 canceled out totally, those y's went away. All I'm left with on the top is 1 x cubed y. So again, sometimes when we simplify these rational expressions, the bottom will go right away. Maybe the top will go away totally and we'll just be left with a 1 in the top of the fraction instead of in the bottom. That's okay. That's actually kind of nice when that happens. We want to simplify this down as far as we can. Now let's go ahead and try this again. Now we have 3 rational expressions multiplied together, so 3 fractions that I want to cancel as much as I can. You can really start wherever you want. Let's try to start by canceling some coefficients. Let's try to cancel some numbers. I see this 15 and this 25. They both have 5's in them. So those 5's are going to cancel away, and I've got a 3 left here, and I've got a 5 left from that 25. Now that's it for the numbers. Okay, so I know that my answer is going to have 5 in the top and 9 in the bottom. Why 9? Well, you got to multiply these 3's together. Now let's cancel some x's. We got x's kind of going on all over the place. Let's try to cancel some out. Well, I can get rid of this x right here with this x from the first fraction. As long as it's in the top and in the bottom, they'll cancel right away. Now let's take care of some more x's. I see an x squared here on the bottom, and I've got plenty of x's to cancel all of those. What I'm actually going to be left with is 3, or cubed, there in the top. So what I end up with is 5x cubed in the top, and the only thing I have in the bottom is the 9. So let's go ahead and make this look a little bit neater. We'll move that 9 over so it's a little more centered. 5x cubed over 9. Okay, so let's take a look at one. Looks a lot more complicated, but what you want to do is factor the tops and the bottoms of these rational expressions right away. Factor these out if you can and cancel what you can. So this x squared minus 9 is a difference of squares, and I can factor that out. Let me get rid of my mark there. Didn't actually mean to have that. I can factor that x squared minus 9 into an x plus 3 times an x minus 3. That's a difference of squares again. I can factor a 2 out of the top in my second fraction, so I have 2 times x plus 2. I can't really factor that x plus 2 into anything, so it just stays put. Maybe it'll cancel with something later. And I can factor my trinomial x squared plus 6x plus 9 into an x plus 3 times an x plus 3. Now, if you're not remembering how to factor, you need to ask. If you're struggling with this idea of factoring things apart, make sure that you ask. All right, now let's take a look at what's going to cancel in these two fractions. Now that I've got everything canceled out, I'm actually going to cancel one of my x plus 3's on the bottom with that x plus 3 on the top. I cannot cancel the x minus 3 because I don't have a complete x minus 3 on the bottom somewhere. So that x plus 3 on the top, that x minus 3 on the top is going to stay put. I can cancel my x plus 2 on the top with my x plus 2 on the bottom. And that's really all I can cancel out. So after I do that, what I'm left with is 2x minus 3 on top and x plus 3 on the bottom. All right, so let's try this again. Remember, you want to factor out as much as you can before you actually start to multiply. You want to factor out and you want to cancel before you multiply. So let's take a look at what we get here. On the top, on the left, I can factor out that 10. On the top, on the right, can't really do anything with it. On the bottom, on the left, I can factor that into an x minus 2 times an x minus 4. And on the bottom, I can pull that 5 out. So it's 5 times x plus 3. What can I cancel out? Well, I can cancel the x minus 4, top and bottom. I can cancel the x plus 3, top and bottom. Now, I can cancel my 5, that's right down here, with the 5 that is in the 10. So what I'm going to end up with on top is 2. That's it. On the bottom, what I end up with is x minus 2. All right, so let's talk about dividing rational expressions. Division is just the different side of the coin from multiplying. This really should not be any more difficult than multiplying rational expressions, except what I've got to remember to do is flip the second rational expression and then multiply. This is just like dividing fractions when you were in, 5th grade or whenever you learned how to divide fractions. So my first step with this is that I'm going to flip the 9y cubed goes on top and the 16 goes on the bottom. And now I want to cancel as much as I can. So I can cancel my 9's because now one is on top, one is on bottom. I can cancel the 4 with a 4 that's hidden inside that 16, and I'm left with a 4. And now I can start to cancel a whole bunch of these letters. I can cancel x squared on the bottom with x squared on the top, and that's going to leave just one single x on top. I can do the same thing with the y's. I've got a y squared on bottom, I've got y cubed on top, so that's going to leave just a plain old y on top. So once I'm all done canceling, then I can rewrite it xy over 4. All right, let's try this again. Things look a little bit hairier, but if you factor these trinomials before you actually try to do the multiplication, this is way simpler. Because what we're going to see, things are set up to work out nicely for us. We will definitely get something to cancel. So let's go ahead and invert and multiply. We're going to flip that second fraction over. But you'll notice at the same time here, I factored everything out. My x squared plus x minus 2, that factored into x plus 2 times x minus 1. My x squared plus 2x minus 3 factored out. And over here on the right, I factored and I flipped. So this x squared plus x minus 6 ended up here on the top and is factored out. Okay, let's get rid of those. And we can see, you can already see the final answer, that we can just start canceling anything that happens in both the top and bottom somewhere. It does not have to be in the same exact equation, same exact expression, rational expression. As long as it's in the top in one spot and in the bottom somewhere else, it will cancel. And we're left with x minus 2 over x minus 4. All right, now let's look at solving some simple rational equations. These are really rational equations rather than rational expressions. When we want to solve rational equations, there's often a list of numbers that can't be answered. And what that comes from is this bottom cannot equal 0. So x plus 2 can never, ever, ever, ever equal 0. So this makes a list of numbers. In this case, that list is only one number. But we can never, ever let the bottom equal 0. Okay, so we're going to solve this. And first what we're going to do is try to cancel as much as we can. So if we factor out the top, again, it's a difference of squares. It factors out into x minus 2 times x plus 2. You see that those x plus 2's cancel. Now, what we have to do is remember that x cannot equal negative 2. If x equals negative 2 came up as our answer, we'd have to throw it away. We can't have x equals negative 2. Now, fortunately, in this case, we go ahead, take what's remaining over there in our rational expression side, set it equal to the 7, and we get x equals 9. Now that is not trying to break our rule. Our rule is that x cannot equal negative 2, so that's okay. This is our answer. All right, well obviously we got to look at one that's not going to work out so well. Notice I've changed the number over there on the right hand side. I've left the rational expression alone. I'm going to do the exact same thing. I'm going to factor out that top. I'm going to cancel what I can. Oops. I'm going to cancel what I can, but I've got to remember x cannot equal negative 2. So take what's left over on that left hand side, x minus 2, set it equal to 4, add over the 2. Uh-oh. Now it's saying that our solution is x equals negative 2. We can't have x equals negative 2. That's against the rules. So in this case, we don't have any solution. So we say that there are no solutions. All right. So that wraps it up for this video. It's time for you to try some of those problems on your own. See how well you did. Remember, if you're having some problems, take the time to rewatch this video, go over your notes. All right, I'll see you in class, and I will see you online.